Hello everyone, we are glad to be here to present our work titled Learning Continuous Exposure Value Representations for Single Image HDR Reconstruction, which has been accepted at ICCB 2023. Here is the outline. First, we will introduce the core idea and the main contributions of our work. One popular method for single image HDR reconstruction is the indirect approach. This method uses a single LDR image as input for a deep learning model. The model then generates an LDR stack, which comprises several LDR images with varying exposure values. This LDR stack is then fed into a conventional stack fusion algorithm. In our case, we utilize Deverbeck and Malik's method to reconstruct the final HDR result. Traditional indirect method use LDR images with predefined exposure value to construct the stack. In contrast, our approach explores continuous exposure value information, constructing a denser stack that includes LDR images with previously unseen continuous exposure value. We call this denser stack the continuous LDR stack. Compared to existing indirect method, our approach, the continuous LDR stack, has the ability to recover a more accurate inverse camera response function, therefore enhancing the quality of the final HDR result. Now, we will proceed to introduce our model and outline the training strategy. First, in order to generate continuous LDR stack, we propose the CVR model, which can generate LDR images with arbitrary exposure values. It is a UNet-based structure and incorporates the implicit function design. But for those exposure values without corresponding ground truth, how can CVR understanding the meaning of unseen exposure values during training phase and generate the reasonable result? To address this challenge, we designed a novel training strategy called cycle training. This strategy involves two branches. One follows the conventional training approach, while the other branch divides the target exposure value into two incremental steps. This divided value is then processed through the CVR model twice, and the sum of these two steps equal to the target exposure value. Through this approach, our model learns explicit insights of exposure values, variations, and gets supervisory signals for exposure value without ground truth. For the sections on experimental result, compared to other existing methods, our work demonstrates competitive performance. Here are some demo videos. The first video shows that our CVR models generates LDR images with continuous exposure value, which are used to construct the continuous LDR stack. The second video demonstrates the effectiveness of our continuous stack design. Through this design, we achieve improved accuracy in recovering the camera response function, leading to enhanced result in the final HDR output. At last, many thanks to others involved in this work. Also, thank you for your attention.